Well, I promised you the knobless cylinders today, and there are 4 sets of these that come in these boxes with the sliding lids, and we have to use them on the floor because they would be too tall for the children used on the table. There's one exercise that could be done on the table. I'll show you that exercise second. So the teacher spreads the green mat on the floor, and this first set, the cylinders differ in all 3 ways. They differ in height, length, width, taking length and width through the diameter by ½ a centimeter between any 2 in succession. So in that way they are like the first set of the knobbed cylinders, but the difference is that they haven't got knobs and they haven't got the little sockets, the holes to fit into, and so they're very much more difficult because matching the cylinders to the holes, you have got something to help you judge size. And of course the difference between the largest and the smallest, see, is very great. Again, this baby one often gets carried about in somebody's pocket. You have to make sure you have it at the end of the morning. Well, they're placed on the mat, and the exercise the children like best, and so this one I always begin with, is to build them into a tower. So you select the largest, and then you let the child see that you're definitely looking for the next larger, and you must put the first one in centrally, place it on the first, you see it all in one movement. Because if, having placed it a bit to one side, you shuffle it about, then the children think that is part of the exercise, or your children get these fussy movements. So you're just going to select them in order and build a tower. At any point, a child must join in. And if your child joins in and obviously knows what he ought to be doing, then you let him take over. Some children like you to complete it, and then they take it down and let them do it. Now the differences are not great, and so it is a difficult exercise, and the children will make mistakes. But if they make mistakes, bad mistakes, the tower will fall over. But if they make mistakes, I find they usually can see that they've gone wrong. It doesn't look right. If they've built a tower like that, they can see something is wrong. And they usually take it to pieces and start again. And only by using them do their eyes become able to judge size. And of course they do become consciously aware of size. Now, is there anything you would like to ask about that? I think it's very straightforward. You will find that at different times, different colours have been used. The colour is not important. I rather like these are barrel dyed and then polished, and it gives a rather softer colour than a hard gloss paint, which to me is more attractive. Now the second exercise I'll show you could be done on the table or could be done on the mat on the floor. I'll do it so it was on the table. In that case you would not need a mat. Again, you sit by your child and you have them in mixed order, and here they have to be arranged in order of size in a line. again, he should be able to see, he has to be able to see something is wrong. If one is in the wrong place, the difference is twice as great. And so between these two as between those two. And so the fault is rather obvious. Most children can see their error. And if they can't, it's only through working with it that they improve, and so there isn't any point in correcting them. If they do it very badly, then naturally we'll give a new lesson. I find this exercise, grading on the table, is easier for the spastic children. These are the children where there's a faulty connection between the hand and the brain, and the movements are very poor, but are trainable. And the more of this type of work they do, the better. And the younger they get help, the better. So, but this is an easier exercise for them than the tower. And again, if you had a really educationally subnormal child, these are the ones with IQs under 50 with us. So you get a child with an IQ of about 25, and then they would need to have every other one. Wouldn't matter which 5 they had, but they could try building a tower with either 5. You wouldn't have them both at once, of course. And there the difference is being twice as great, they're more likely to be successful. Or again, there was a problem in the way they use their hands. They could be shown the grading exercise first. And again, it wouldn't matter which set they use. They would only have one set at a time. But it wouldn't matter which they use. And again, so then when they were successful with 5, sometimes one 5, sometimes the other, then they could have all 10. But that's only if your education is subnormal children. Now I'm sure you are noticing that I have one orange that is a little bit different in colour. And that is because, it's not meant to be, it's because one of these got lost. And the new ones came in, where they had used a different colour. And so I've got to get them spray painted all the same colour. But it shouldn't be like that. You wouldn't have it like that in the classroom. Sometimes a really severely spastic child is better using just 5 of each at first, because they have this real difficulty in manipulating anything. But the more fine work they do, the more they are trained. Their hands become trained. Now there are 4 sets. Really approximating to the 4 knob cylinder sets. The set I have here is blue. As I say, it doesn't have to be blue. I've always had it made in purple because the children do love a purple. And then last time I see they made it in blue, which I'm rather sorry. And this one, again, varies in all 3 dimensions. But this time the tall one is the thin one and the short one is the thick one. So the gradation just goes the opposite way. Again, you have it on the mat. Possibly you don't even have to demonstrate to many children. You have shown them how to use one set, then it's obvious that the other sets are used in the same way. But there are always some children who like to have the demonstration. Now this one is very much more difficult. You have to be absolutely perfect tower. I'm afraid my hands are shaking all over the place. Well, you do it. You can see what you're meant to do. I sometimes find with these that it's better for the child to sit on the mat and build the material on the floor, because the mat is the surface is a bit rough. Or again, you see, it can be graded. Yeah, each set really does get difficult. Here they're all the same height. And so these will make a really tall tower. You can easily see that the children couldn't manage them on the table because they would become too tall for the child to reach the top. I don't know if I'm even going to try this one. You can see what it's meant to be. It's all right until you breathe. And then we can again arrange them in a line. Both exercises are nice. Of course, children do prefer the tower. This is a very nice exercise because it does show that they're all the same height. The differences stand out very well when they're graded in a line. And with all of them, the educational subnormal could have just 5 every other 5 to begin with, and in some cases a spastic child here, the fourth set cylinders differ only in height by half a centimeter between any two in succession. And this is an extremely difficult tower to build because it means that it is the same thickness all the way up. This table has a bulge in it, that's why. So you do have to build a most perfect tower. It looks very straight, very easy to build the Tower of Pisa. Yeah. Now that is by far the most difficult. Then the other exercise is to grade it. Grading exercise is easier than building the tower. And the purpose is understanding dimension, and the child begins to observe dimension in the environment. He reaches this abstract conception of size. And of course it's very good for hand-eye coordination. It's coordination of movement, because it's a very delicate handling required. And of course it's, again, one of the materials is the basis of mathematics. You see, you understand dimension, then a little later you will understand measurement. And there's 10 of everything always, which is the basis of the decimal system. We must have a talk one day about how every piece of material does lead on. It just doesn't finish with the cylinders, it always leads on. Dr. Montessori always said that everything she did with the children was a hook that led them on to the next stage. So we have to see how some of that happens. All right.